Okay, so next we'll look at the final exercise from the previous lecture. We will show that the K topology is strictly finer than the standard topology on the reals, but is not comparable with either topology of the Sorgenfrey line or the Michael line. So proof. Since the set K is not closed in the real line, the Sorgenfrey line, or the Michael line, the complement of the set K is not open in these spaces, and hence none of the topologies of the real line, the Sorgenfrey line, or the Michael line are finer than the K topology. On the reals. Now, since every basic open set in the real line is also a basic open set, in the space of reals with the K topology, the K topology is finer, and in fact is strictly finer than the standard topology. On the reals. Now the half open interval from A to B, where A and B are real numbers, such that A is less than B, is a basic open set. In the Sorgenfrey line. Now, a basic open set in the space of reals with the K topology that contains the point A is either an open interval from C to D, or the relative complement of the set K in the open interval from C to D for some real numbers C and D. In either case, C is less than A, which is less than D. Now, since C and A are real numbers such that C is less than A, there exists an irrational number R such that C is less than R, which is less than A, So notice that the open interval from C to D is not contained in the half open interval from A to B, and the relative complement of the set K in the open interval from C to D is not contained in the half open interval from A to B. Since the irrational number R is in the relative complement of the set K in the open interval from C to D, which is a subset of the open interval from C to D, and the irrational number R is not in the half open interval from A to B, since R is strictly less than A, and so there does not exist an open neighborhood U of the point A such that U is contained in the half open interval from A to B, and hence the point A is not in the interior of the half open interval from A to B, and so the half open interval from A to B is not open in the space of reals with the K topology, since the half open interval from A to B is not equal to its interior. And thus the K topology is not finer than the lower limit topology, and so the K topology and the lower limit topology are not comparable. Now the singleton containing the point R, where R is an irrational number, is a basic open set. In the Michael line, now for every real number x, a basic open set in the space of reals with the K topology that contains x is either an open interval from A to B, or the relative complement of the set K in the open interval from A to B for some real numbers A and B. In either case, we have that A is less than x, which is less than B. So since A and x are real numbers, such that A is less than x, there exists an irrational number S such that A is less than S, which is less than X. So notice that the open interval from A to B is not contained in the singleton containing the point X, and the relative complement of the set K in the open interval from A to B is not contained in the singleton containing the point X. Since the irrational number S is in the relative complement of the set K in the open interval from A to B, which is a subset of the open interval from A to B, and the irrational number S is not contained in the singleton containing the point X, since S is strictly less than X, and hence the point X is not in the interior of the singleton containing the point X, and so the singleton containing the point X is not open in the space of reals with the K topology, since the singleton is not equal to its interior. That is, no singleton is open in the space of reals with the K topology, and in particular, the singleton containing the irrational number R is not open in the space of reals with the K topology, and hence the K topology is not finer than the topology of the microline, and thus the K topology and the topology of the microline are not comparable. Now, since no singleton is open in the space of reals with the K topology, the space has no isolated points, and as the microline has uncountably many isolated points, the space of reals with the K topology is not homeomorphic to the microline. So next, we will show that the space of reals with the K topology is not regular. So proof. Notice that the set K is contained in the half open interval from 0 to 1, inclusive of 1, and that the number 0 is not in the set K. Now a basic open set containing the set K is an open interval from A to B where A is less than or equal to 0 and B is greater than 1. Now a basic open set containing the number 0 is either an open interval from C to D, or the relative complement of the set K in the open interval from C to D for some real numbers C and D. In either case, C is less than 0, which is less than D. Now, without loss of generality, we may assume that D is less than 1. And so we have that C is less than 0, which is less than D, which is less than 1. Now, since 0 and D are real numbers, such that 0 is less than D, there exists an irrational number R, such that 0 is less than R, which is less than D. That is, the irrational number R is in the relative complement of the set K in the open interval from C to D, which is a subset of the open interval from C to D. Now, as the point A is less than or equal to 0, and 0 is strictly less than R, the number A is strictly less than R. And as R is strictly less than D, which is strictly less than 1, and 1 is strictly less than B, we have that R is strictly less than B. That is, the irrational number R is in the open interval from A to B. And hence the intersection of the relative complement of the set K in the open interval from C to D with the open interval from A to B is not empty, and the intersection of the open interval from C to D with the open interval from A to B is not empty. And so there does not exist open neighborhoods U of the point 0 and V of the set K such that the intersection of U and V is empty. And since the set K is closed in the space of reals with the K topology, and the number 0 is not contained in the set K, the space of reals with the K topology is not regular. Now, since the real line and the Sorgenfrey line are regular spaces. And the space of reals with the K topology is not. The space of reals with the K topology is not homeomorphic to the real line. And the space of reals with the K topology is not homeomorphic to the Sorgenfrey line.